2 mornings a week, I joined Tin Mountain research scientists in their ongoing data collection project. Each morning at dawn, we completed point counts in which you walk to a series of exact points like the one shown on the right, and stand for about 10 minutes to keep track of all birds heard or seen during this time. After experiencing the collection of data, I was ready to begin using it to answer some questions. Based on the point counts and my research into New Hampshire Audubon Society's data about birds, I was drawn to 3 particular species. A few years ago, New Hampshire Audubon published models predicting how temperature increases would impact species in New Hampshire, using past data and temperature predictions. The Audubon Society has used data to predict the effects of temperature rise on bird populations if our average temperatures rise 1.5, 2, and 3 degrees Celsius. These models and the Tin Mountain data inspired me to further examine the American robins, the purple finches, and the blue-headed vireos. First came the exploration of the American robin, a very abundant species on the Tin Mountain property, and a species considered to be at risk by the New Hampshire Audubon due to climate change. The 2 major concerns for the species are spring heat waves and wildfires. These wildfires lead to the destruction of food sources and habitats. These are both weather events that northern New Hampshire and many of us have experienced in increasing in recent years and decades. As you see on this map, they have started to and will continue to lose much of the southern end of their summer range as these events become more frequent. And we will see them going farther north as their range decreases. The purple finch is the state bird of New Hampshire, so naturally I was interested in the abundance of this beautiful species over time. Spring heat waves and heavy rainfall are 2 of the major threats to purple finches. Both of these events endanger young birds in the nest, leading to a lower survival rate and therefore a shrinking species. Just like the American robin, they are losing the southern end of their summer range as they move farther to avoid these weather events. The 3rd species I researched and analyzed was the blue-headed vireo. This bird is considered to be at high risk of the effects of climate change in our area. This is due to both spring heat waves that put young birds at risk and urbanization that destroys their habitats. The blue-headed vireo is also a bird that migrates later in the spring and fall, so I had a personal interest in the effects of changing local temperatures on that migration process. Before diving into analysis of the data of these 3 birds, I researched what is known about temperature changes in our region. The University of New Hampshire conducted a study of the maximum and minimum temperatures from 1895 to 2012 in northern New Hampshire. As you can see in these graphs, though the temperatures fluctuate greatly throughout the years, overall there is an increase in the minimum and maximum average temperatures. With these temperature increases in mind, I organized the data that we had collected at Tin Mountain. I began by exploring the correlation between temperature and the abundance of American robins on the Tin Mountain property. In order to do this, I began organizing the data in Excel, looking at the abundance through each season. After organizing the data, I dove into statistical analysis for the first time in my life. I relied on the researchers at Tin Mountain to help me lose less of my sanity as I learned about statistics. With the American robins, I used a tool to look at the correlation between temperature and abundance. Correlation is a -1 to 1 scale in which any number above 0.70 in either direction indicates a correlation in the data. As you can see on this data table, when I ran correlations in all seasons, there's neither a positive nor negative correlation. This means that in our data at Tin Mountain, there is not a correlation between temperature and abundance of American robins during this time. The second bird I focused on was the purple finch. It turned out that we did not have consistent enough data on this species to draw conclusions about abundance. This stresses the importance of the work researchers are doing in collecting climate data consistently over long periods of time. The 3rd species I analyzed was the blue-headed vireo. I originally questioned if there was a change in their durations of stay, meaning was there variation in the date they first arrived on the Tin Mountain point counts in the spring to the last day they were seen in the fall. To do this, I used the Julian dates, as shown on the right, where each day of the year is assigned a number, making it easier to compare dates year to year. After finding the dates of the blue-headed vireo arrival and departure, I was able to analyze if their lengths of stay this by running an ANOVA factor or an analysis of variance. This is a tool that determines if there is a significant variance between data groups. As shown in this table, the ANOVA gives you many pieces of information. My focus was on the p-value, or the probability value. When this value is 0.05 or lower, it indicates that there's a 5% or less chance that what we are measuring is random. This means that we can conclude that a relationship does exist. In this case, our results showed that the length of stay of the Vireo had increased. However, because the time period I was looking at was only 4 years, I felt that I could not conclude that the effects of climate change were occurring. So I ran a correlation with temperature. I did not find a correlation between temperature and blue-headed Vireo length of stay. Therefore, I found that there was not a significant conclusion about the impact of climate change to be drawn from this blue-headed Vireo data. When I set out to complete this study, I knew that I was not going to find the world-changing cure to climate change or even proof of climate change within our local birds. And you may ask why. Climate change is something that we know is taking place, but must be understood by looking at decades and centuries of data. This project allowed me to experience the data collection and analysis, but I then turned to other scientists' data to better understand what is happening to our birds statewide and nationally. To do this, I used research of the New Hampshire Audubon Society. As I referenced earlier, the Audubon Society has used past temperatures and bird activity to predict the threats that species will experience as the temperature in our environment increases in intervals 1.5, 2, and 3 degrees. These temperature increments were used based on models of the future. 1.5 was chosen because that is the increase in our environmental temperature that's imminent if we do not take immediate action. It has also been predicted that at our current rate, we will experience 2-degree increases by 2050 and 3 degrees by 2080. On this visual, each temperature increase is represented by a mountain. The numbers in red show the number of species that are considered by the Audubon Society to be high vulnerability. The orange numbers are considered to be moderate vulnerability, and the yellow numbers are considered to be low vulnerability. As you can see, when we climb toward the increase of 3 degrees Celsius, we see a rise in the number of species at high risk and a decrease in what would be considered healthy species. I know what I have shared with you sounds like all bad news, but I don't wish to leave you with a feeling of helplessness. I would like you to leave empowered. We as humans can impact these temperature changes. The UNH study that I previously discussed was able to make predictions about the future temperature increases. They based this on 2 models of emissions that human activity causes. As you can see, in both the maximum and minimum trends, there are 2 graphs. Red representing a higher emission scenario, and blue representing that lower emission scenario. As you can see, in both the maximum and minimum trends, the temperature is increasing. However, when we look at the blue graph of lower emissions, this is happening much less drastically. This means that if we can reduce our emissions in the coming decades, the temperature will rise less and bird species here in New Hampshire will be impacted less significantly. But how can we do this, you ask? I have broken down actions we can take into 3 categories. Some easier daily habits that we can strive for, ongoing commitments to think about annually and as we make decisions throughout our lives, and long-term goals that will require our time and patience. You can see in this chart actions to take in each of these categories. You may already integrate many of these into your daily life, but to protect our local species, we are all going to have to commit to more of these habits and encourage those in our community to do the same. I will leave you with this. I took this photo on the summit of Mount Pierce in Crawford Notch a few weeks ago. Upon summiting, I entered the utopia that many of us experience living in this valley. Standing on these peaks and looking at these views, it makes it almost impossible to grasp that climate change is occurring here. But it is happening. It's happening right around us. We must stop to look at the data and take the required steps to prevent negative impacts on our habitats. It is through these actions that we and our local species can continue to live in this utopic environment. Thank you for engaging in this discussion with me and taking actions to keep our local and global species healthy.